Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Hi, and welcome to the SEI Podcast Series. My name is Suzanne Miller, and I'm a principal researcher in the SEI Software Solutions Division. Today, I am joined by Jeff Gennari and Sam Perl, who are joining me today to discuss their recent collaboration with OpenAI that resulted in the development of 14 recommendations for evaluating large language models for cybersecurity tasks. Welcome, Jeff and Sam.
Thank you.
So good to have you here. You've both been guests on our podcast series before, but not everybody's going to know you. So for those members of the audience who haven't seen your previous podcasts, and we will link to those in our transcript, by the way, let's start off by having each of you tell us a little bit about yourself, what brought you to the SEI, and tell us a little bit about the work you do and what's the coolest part of your job. And why don't we go ahead and start with Sam?
Sure, thank you. So for me, my journey to the SEI was a bit of a long one. I started out as an undergraduate and a graduate student at Carnegie Mellon University. And in my graduate student days, some of my professors were from the CERT department and other parts of the SEI. And I was very sort of engaged with cybersecurity and the kind of courses that I was taking. And really impressed with the faculty. So I went off and did some consulting in the private sector for about 9 years, kind of, not related to the SEI, but still working in cybersecurity. And then just kind of somewhat randomly one day, kind of got the opportunity to interview with the SEI and CERT again. I had moved back to the Pittsburgh area, and I was just thrilled to be able to join that team. And so was able to transition into a more research role, kind of looking broadly at problems that would affect multiple industries and people and consumers, and really excited and happy, to be here and just have had a wonderful career here. I've been here close to 13 years at this point. So lots of great research in the areas of incident response and cybersecurity in general as well.
Well, and we're happy to have you here, I have to say. So, Jeff.
Thank you. So my journey to the SEI began about 20 years ago, actually. I was fortunate enough to get a job in an operational context at CERT, doing computer security incident response, vulnerability remediation. And as I've been here, we've evolved to become more research oriented, tackling different aspects of cybersecurity, doing a lot of engagement with Carnegie Mellon proper. And so I've been thrilled to see how the SEI has continued to evolve and adapt into different aspects of software engineering, and in particular cybersecurity. And I think that the work we're going to talk about really touches on some of that, or is really evidence of that evolution.
All right. So thank you both. And today we're here to talk about recent research efforts to evaluate the use of large language models for cybersecurity tasks. And can we start that by exploring the current landscape for AI in cyber? Beyond code generation and evaluation, what applications are available for large language models in the cyber landscape?
So I think, as you ask the question and I think about the answer, I think the possibilities are quite large. And I think that's part of the reason we wanted to write the paper in the first place was, every problem that we have in cybersecurity, vulnerability exploitation, vulnerability discovery, secure coding, risk management, policy concerns, can be impacted by large language models, AI chatbots in particular. And so I really think that just about anything has the opportunity to be impacted by this space. And the space is also, I think, changing kind of how we think about cybersecurity. It's opening up new attack vectors. The attack surface of our systems is changing when they have AI components. And so I think when we started this work, it was really about, how do we use this technology in different parts of cybersecurity effectively, right? You see evaluations for individual areas, right? How well does an LLM or an AI-powered assistant do a particular thing, like diagnose a vulnerability or suggest a fix or something like that? But we really don't know how it'll work in a general sense. What are the limits? What are the risks and trade-offs? So it's a long way to answer that I think that everything is in play.
Well, that's what I was actually going to say is what you're really saying is there is a very large landscape here. It is not a small landscape in terms of how LLMs and AI in general either contribute to vulnerabilities or contribute to defense against those vulnerabilities. So this is really important work. Sam, did you want to add anything to that?
I thought that was great. I fully agree with the sort of sentiment that this isn't going to be an enormous space. I was actually thinking, boy, we're going to need a whole new podcast just to talk about that one question, right?
Well, we can do that.
Yeah, just because there's so many, in my opinion, but sort of both emerging, kind of uses of AI in cybersecurity. The other interesting thing, which I would say is somewhat surprising to some people, although usually not the insiders, is like AI has been, or sort of machine learning, has been used in cybersecurity, right, quite extensively for a very long history. Spam filters have been using machine learning for decades. Intrusion detection systems were originated, right, using statistical models of traffic and traffic analysis and classification. So we're talking about, right, much more advanced sort of techniques in those areas, and what, will come next and how will it be used. And in my opinion, it's sort of like a very large field, right? And we're already seeing lots of extensions to existing platforms or existing tools that are now, kind of incorporating generative AI technology to allow them to be more easily used by their existing users, or to attract new users, or to, in some cases, try to replace users entirely, right? Getting fully autonomous. So yeah, a lot of it breaks down into, kind of what kind of task are you trying to do, and whether or not an LLM sort of powered model is the right one, or do you want to choose a different kind of AI model, of which there are many. And, so I think there's an interesting also kind of research area, which is one of the fun things about being right at our university, where we have both the academic departments working on building the new models, and then our institute looking at kind of how do we use these and apply these correctly, appropriately and correctly in security. So essentially, right, we get the best of both worlds to sort of like play in that research sandbox. It's really an amazing place to be.
So there's one aspect of LLMs that we've heard about in the press, and I'm not sure everyone that's listening may know what they are and what their effect is. This is LLM hallucinations. And can you talk about sort of what are they and what are the ramifications of those in particular for the cybersecurity domain?
Sure. So I think it's a simple concept where you ask a LLM a question and it provides an answer, and some percentage of those answers are going to be just inaccurate, right? It's going to make things up. A lot of that has to deal with how the LLM is, the nature of the technology itself, and what's actually happening behind the scenes. But so my personal experience working with LLMs in the security context is that the real challenge isn't that the LLM is wrong. It's that it's very hard to detect the wrongness, because it's one wrong thing in a mostly right answer. So they're actually very good at giving you approximate answers. At least this is anecdotal. I'm sure there are numbers to back this up. Sam probably knows them. But the answers are generally they sound right to an expert eye, but a little bit of it's wrong. And it's that little bit and the difficulty in detecting the little bit that can be really insidious and really, make it harder to build an overall trust in that the system's doing what you expect it to be doing.
Okay. Sam, did you want to add anything?
No, I think that was a great answer. I think hallucinations tend to get a lot of attention um, from people, but just like any other kind of tool, right? You may not, maybe you shouldn't expect things to be entirely correct all of the time. Certainly, working with humans, we don't have that expectation, right? That people always know everything, and that they can also cite to the exact source of the original, kind of thought that they have had. So yeah, it is complicated though, because we in some contexts have the expectation that if you're going to submit something or if you're going to provide a written answer, right? And I tell my students this all the time: if you're going to provide a written answer and the answer is, lifted or partially informed by another source, you need to cite that source.
Right.
And LLMs have a pretty hard time with that. And again, as Jeff said, the nature of the technology kind of on the back end and the way in which they were designed, right, leads to sometimes they make things up. And it's actually not that strange if you think about it, because if you're going to take a lot of the text on the internet and use it to train something, it turns out that a lot of the text on the internet is also made up.
Sure.
Right? We write fictional stories all the time. We write thoughts which may or may not be true or entirely true. And if we're going to basically just use most of that, it's very difficult to determine like, oh, this one's a fact and this one's not a fact in all cases, right? So, and in some cases, right, if you're a fiction writer and you're using an LLM, you don't want it to be giving you facts. You want it to be making things up in some cases.
That's fair.
Yeah. So yeah, it's kind of like, well, wait a minute. What do we want to use this for? Which contexts do we want it to be factual and which ones do we not want it to be factual? And how do we enforce that? And how do we verify it? And I think that sort of leads us into like, how do we improve evaluations for different contexts, right? Now that we have something which I think we haven't had before, at a scale in which it exists, and an accessibility in which it exists. And so now we're trying to figure out what do we do about the evaluations for every different kind of context. And I think we were trying to make our small contribution for the context that we tend to work in, right? Cybersecurity. What should we think about when we talk about like, how are these going to be used and how can we evaluate and verify and validate them?
And so that leads us to your blog post, where you talked about 4 different categories and 14 different recommendations for evaluating LLMs, specifically for cybersecurity tasks. And I'm not sure how you want to do this, but can we give our readers an overview, at least an overview of the 4 sections and maybe some of the more interesting recommendations or more possibly controversial recommendations, if there are any, that came out of this research in terms of evaluating LLMs for cybersecurity. And just for our audience members who want to take a deeper dive, we will include links to both your blog post and the paper that it's based on in our transcript. So this is not you don't have to take notes. This is not the only place you're going to hear about this stuff. Sam, do you want to go ahead and continue on and sort of get us started with this?
Sure. I'll just read all 14, that'll
yeah, you know how we love that.
No, so I think, what our blog post was about, and in fact, so we wrote a paper, which was a collaboration with the team at OpenAI. There was one of their research team members and their security team members. So we did a lot of back and forth with them, but ultimately came up with, I think trying to capture some of what we felt were existing gaps with what we had seen in how evaluations had been being performed, and why we thought that maybe the cybersecurity domain was going to need a different kind of evaluation from what we had seen before. And I think a lot of it was initially reactions to what we thought of as sort of an exam-based approach to evaluating kind of what this knowledge model, sort of language model, what knowledge the language model had picked up as it was being trained, right? That was what a lot of the evaluations were. And so it was like, if we ask a series of questions and it can provide answers to those questions, then, right, we have we have replicated, right, the sort of capabilities of what a human would be able to do in that area,
right,
at a low level. And I think in cybersecurity, even then, we were trying to say, look, that's just not the case. That's number one, that's not the job, right? And number two, even if we use exams, right, because I give my students exams all the time, I know Jeff does too. If we use exams, right, for humans, what is the actual implication of using that same type of exam for an LLM? It just doesn't fit the same way. It doesn't give you the same kind of predictive power, right, than an exam for a human gives you. So what is the equivalent of trying to evaluate the knowledge that an LLM has in security, and for what kinds of security, right? So that got us into sort of theories about security and the different knowledge domains. So that's sort of the just teeing it up. But a few of the things that we wanted to make sure we included were like, how do we get things away from the exam model and more towards like the real world tasking or activities that practitioners would be performing, right? And so it's like, this ties into the problem, right? How big a problem are hallucinations? Well, we don't know. It depends on the task. If they're trying to come up with, the right command to input into, to discover if a vulnerability is present, there might need to be some kind of, experimentation that can be done. There may not be an existing factual answer that has already been published. We need them to try things that are somewhat new and novel. On the flip side, right, if there's a command that they should not run because of detection capabilities on the other side, then, right, they're going to give the game away if they run that command. So there's, lots of nuances involved when it comes to these things. So I started to get away from the answer a little bit at the end there, but I'll probably turn it over to Jeff for articulating some of the, practices that we talk about.
Yeah, just to add to that, because I think the individual practices are in the blog post and I could read through them, but the original, thinking back to the original idea of the collaboration with OpenAI was, we have a lot of experience in cybersecurity. They're building, ChatGPT, and they're getting asked questions about, how do you evaluate this thing, this new creation, to make sure it's doing things in a secure way. And so when we originally looked around to see how LLMs were being evaluated, it was the exam model. You would read articles, news stories about how ChatGPT can pass the SAT, for example, and that resonates with people because everyone's taken the SAT who's went to a college, or at least they're familiar with it. So saying that carries a lot of weight. But when we started to go down the path of what does that look like for security, because we do have security examinations like CISSP and those they serve a purpose, but they don't make you an expert, right? They're like they help serve as a checkpoint, but really to be an expert or considered an expert, it's a bit more nuanced. There's an experiential component. You have to look at your accomplishments, and so the exam model just didn't feel right because it was skewed towards the types of things that LLMs are good at, in particular factual recall. And we found that in security, pretty much across the board, regardless of what specific area you're looking at, there is a bit of there's trade-offs that are made and risk assessments and nuanced reasoning that you're not going to get through a multiple choice exam. And so a lot of the recommendations are from that frame. So like designing the task so that it doesn't skew towards what the LLM is good at. right? So having tasks that aren't just multiple choice questions, true or false answers, they require a bit of nuance. There's some complexity. We're not saying that there's no role for that, but you can't make, you have to couch your, what you take away from the assessment appropriately. So making evaluations robust, right? So you want to avoid spurious results, right? You want to be careful in the data that you use to help set up the experiment. Really, you should think of this more of an experiment, less of like an evaluation. Right? You really want to design a task that you would maybe design for a human with some caveats, so that you're prompting the LLM. No pun intended there, but you're trying to get a more reasonable reaction, not just a direct answer, right? And that the third area in the paper and the blog post was to properly frame your results, right? So don't over extrapolate. Just because you do well on one evaluation doesn't mean you'll do well on all of them. And to me, when I look back on what we wrote and the journey we took in writing it, a lot of it just feels like common sense. I mean, it's a little eerie that in how similar it is to teaching students at a university, but I think that's more in line with the nature of the technology.
I was going to say that metaphor, I think, actually works well, because you can think of an LLM as being a student of whatever topic it's being asked to deal with. And it's just like a student, it's going out and researching what's available for me to use to answer the questions that I'm being asked. And excuse me. And that not all students perform equally, for one thing, and not all students access the right things, and not all students interpret things appropriately for what they've been asked to do. But I particularly resonate with the idea you're talking about in terms of understanding what is the task in general that you're asking this LLM to do. Because if that task is something that, if I don't know the general answer to the question that I'm asking the LLM in a cybersecurity or some other technical area, trying to say that they're going to give a better answer than I would, given I had access to the same resources, probably, that's probably a fallacy. And so we have to, in my mind, the amount of trust that we put into these LLMs has to be balanced by understanding what their limitations are. And that, I think the evaluations you're talking about address that. Am I on the right track with that?
Yeah. And I think, when figuring out, so ultimately we want to know how to best use this technology in cybersecurity for a variety of specific tasks. I think part of building trust, the technology can be helpful, is evaluating it in a realistic way, right? So just having it pass, a multiple choice exam, looks good on paper, but now you have to use it on the job in a possibly sensitive operation or task,
right?
And I would need a little bit more.
So
it wouldn't just be. Oh, go on.
One of the things that Sam mentioned was citations, right? The ability of LLMs to provide the logic behind what it is and that they have provided to you. Is that an area that LLMs are sort of working on building up? Because I know in some of my own work with LLMs, that has been a frustration for me, is that it's like, where'd you get that from? When I ask for, and what were your citations for that? It's not always very satisfactory. Is that a particular area that for cybersecurity we need to be careful about? Because if we don't know where they got the information, it could be, as a matter of fact, malware or some other kind of attack. Is that something we should be concerned about?
So yeah, I think it's a complicated question with a complicated answer. I will caveat it by saying, I'll caveat it by saying, I think that the companies and developers who are working on generative AI models, particularly LLMs, and specifically, are trying to improve their ability to provide citations. So with every version, right, or new model that comes out, there's an attempt at improving that capability. I call it ongoing kind of research, right? And that's in general, that's across all different kinds of contexts that they're being used in. And cybersecurity is not the only area, that is dealing with that problem. There are other areas that are basically, kind of waiting to, to figure out how that problem is going to get solved before they really heavily deploy, the use of LLMs for, kind of more serious formal work. But that said, I mean, a lot can be done even today with the sort of limited ability to provide citations. So yeah, it's an ongoing challenge. The other thing, I mean, security, again, one of the things we talked about a lot is even within security, there's a lot of different domains, vulnerability management, reverse engineering, penetration testing, policy and risk management, kind of the usable security, all right, for human and computer interaction. All of these are like really different from each other in many ways. And in some cases, right, you need citations, and in other cases, like you may not. You may just need to get something that works. So yeah, it's complicated even within cybersecurity. It's not cut and dry from one task to another. So we talked a lot, and including in the paper, about how these different domains will also potentially need different evaluations as well. Like you can't take a secure coding evaluation and use it for pen testing. It's not the same task. Um, so that's part of my answer too, is that I think even within these fields, using cybersecurity in particular, is just the one we know best. It's going to be complicated to evaluate the performance of these tools, even from one task to another. That's why we really focus on what are you trying to use this to actually do, and how are you kind of evaluating its capabilities in the context of somebody who's very good at, let's say, reverse engineering, for example.
Jeff, did you want to add anything into that?
No, I think Sam captured everything quite well. I guess perhaps one thing that I find particularly challenging is that the pace of advancement, and this might be slowing perhaps a little bit, but the pace of advancement over the last 2 years has really been disorienting in trying to figure a lot of this out. So I actually do commend a lot of the companies and researchers out there for, at least recognizing these types of problems with their technology. I could think of analogs in other, other areas that took much longer to recognize security as something that should be taken seriously. So, it sounds, even just looking back at the paper, which we published in the end of February, middle of February, things are different now. And I think that pace is really hard to keep up with. And I'm heartened by the fact that a lot of these organizations are, recognizing that there's an opportunity and also some risk that they have to mitigate.
So these are a couple of challenges. Are there any other particular challenges using LLMs in cybersecurity that you want our audience to be aware of? We've talked about the pace. We've talked about I'm going to say the breadth and diversity of the domain. And we've talked about sort of areas where there are particular known gaps in terms of what the LLMs in particular can do. But are there any other areas that you say, hey, if you're dealing with LLMs and you're concerned about cybersecurity, here are some things that you're going to have to be up against?
So there's one thing that it's not really in scope for our paper, but in AI security, I think in general, and it's that it's just software, right? It's a remarkable technology, but it's still just software, and it has weaknesses and vulnerabilities itself. So I think where evaluating this technology in my business, I would keep in mind that it's not magic, and that there are some trade-offs you have to make from your own cybersecurity perspective, not what the LLM will do for you. And I don't hear that I'm starting to hear that conversation a little bit. For example, when you put information into an LLM, the LLM generally has that information. There could be a privacy concern there. But other things like genuine, like run-of-the-mill software vulnerabilities. I'm starting to hear a little bit more of that, and I think that folks using this technology should keep that in mind. It's software, it has bugs, and some of those bugs are security relevant and can have bad consequences.
Right. Even the most wonderful magic has its problems. And you say it's not magic, it's just software. But I can tell you from at least my first encounters with ChatGPT, when I first heard about it, it felt like magic. And I think that's part of it's part of the beauty, but also part of the challenge is it does feel like it's like it's not just an evolutionary step, it's a revolutionary step in our ability to access information and get much more complex answers to complex questions. I think that aspect of it is back to your evaluation, understanding what it is you're evaluating and not just giving the exam version of the test, understanding the complexity of what you need to evaluate, I think is one of the things that on the face of the, of the LLMs, it looks like magic. And so you've got to get past that view and think about it. This is just software, and how am I going to evaluate software? And for cybersecurity and other things is going to be important to the evolution of this whole area. As we become more, as people are becoming more enamored of it and to a certain extent more dependent on it. So this is you said at the beginning, this is a very rich opportunity for research. But in terms of what we're talking about here, the cybersecurity aspects of LLMs, what are some of the transition things that we have available, this transition resources that we have available to people to help them to get more knowledgeable about this area and to provide them with some practical ideas about how to apply LLMs to cybersecurity tasks, and conversely, how to evaluate the cybersecurity of their LLMs? What have you got to offer for them?
Are you talking about SEI specifically?
SEI and the general general resources, not just SEI.
So I think there's no lack of research, I think, in this area. So our own blog, is full of specific posts applying LLM to different problem sets and domains, using it to help improve software engineering. So there's lots of information out that we put out specifically to support, engineers and decision makers. I think so more broadly. It's kind of the usual things, right? So all these organizations, all these companies that are producing LLMs, I think are trying their best to put out guidelines and guidance for proper use. Sam, I don't know if you have anything else specific you've encountered.
I would just say, I think, because I've been trying to do my best to, read as much as possible. And there's a lot coming out in terms of both kind of direct results of attempting to apply LLMs to cybersecurity operations related activities, as well as many of the other domains that we talked about, that are in cybersecurity and that we mentioned in our blog post. So I would definitely agree with Jeff. The SEI blog has other groups at CERT and at the SEI, and in our AI division, making postings on using LLMs in different contexts, and then also in some cases evaluating, their performance. I've definitely seen a lot of research of evaluating the performance against existing data sets, or sometimes often new data sets that have to be collected just to perform the evaluation. And I think that's probably a direction that we are going to see a lot more of, right? Is to put together some kind of data set that, typically is going to need to be very large, and in many cases heavily curated, and then, used in some kind of evaluation. So if you're looking at, let's say, vulnerabilities or secure coding, we have a team that just focuses on secure coding and has been doing that for decades. Right? They've been doing their own attempts at evaluations, and, they say, listen, here's some code, tell me what the vulnerabilities are in it, and then attempting to use LLMs to do that classification type of problem. But also, if you could find one, why not fix it, right? That's a somewhat new capability, because now you can generate, right, code. Can you generate code that is secure? That's been a big problem, in the space of just general software engineering. And initial results, right, from LLMs, at least in the first iterations of these models, has been that the code that they generated was not entirely secure. Although I expect that to get better, right? Now that as Jeff said, those companies are taking that pretty seriously, right? If you're trying to generate code and it's being generated insecurely, and people are telling you that, you're listening, right? And you're doing what you can to fix it, on the back end, to say, how do we improve these models so that when they do generate something, what they do generate has more security. I think, it's good business practice too, to do that, because, your customers, that's what they want. So, yeah, I think it's really interesting, wide open again space. And I think, right, I will go back to the blog post and say, one of the most important kind of things that we wrote in there is to really be careful about overgeneralizing your claims. When you make a claim, right, because this technology, as you said, it can feel like, wow, this is something we haven't had before, right? This is something we haven't had before. Turns out we ask a lot of questions and we want complex answers, right? And this is getting a lot better at doing that. But once you start getting into those more niche areas, maybe the answers aren't quite as accurate as the more generalized knowledge that you just find a lot more information about on the internet. So, you get into other issues when you start getting narrower and narrower and narrower, which is what sort of some of the professional, activities like in cybersecurity tend to get pretty narrow pretty quickly.
Sure.
Right? Yeah. So, anyway, yeah, I think, I'm excited to kind of continue being able to do the research in this area. It's an exciting area to be in.
So going to that, what's next for you both on the research front? What are you going to be working on next, and what can we talk to you about in a few months?
You can go first, Sam.
Well, so I mean, I'd say I've been doing some interesting kind of collaborations. I've actually been working with a team of lawyers over the past few years. One of the things we did was look at, when the GPT-3 model came out, we kind of had this, collaboration where we said, well, what would be the impact of something like this? This was before ChatGPT. So we wrote, how that might have an impact on patent law. And, that was an interesting paper. And we kind of have continued to collaborate on papers of that nature. So what is the impact on sort of law, which uses a lot of language, and, often requires a lot of citations as well. And in my opinion, right, I think there's a lot of synergies between kind of legal aspects and cybersecurity aspects of tasks, right? Like, stuff is within rules, and you use a lot of precedent, right, and experience and history. So yeah, I'm pretty excited about kind of continuing to collaborate on what impact these technologies have on law, along with, right, the cybersecurity implications. But I've also been starting to look at some of the aspects of what does it mean to define things like fairness? What does it mean to define things like responsible, right? And then my general area is often on kind of the data of cybersecurity. So in my case, it's more incident response. What do we do when we have an incident? How do we track it? How do we coordinate it? How do we kind of reduce the amount of time that it takes our teams to recover and respond? So yeah, I expect to be doing research in all of those areas. Yeah.
And for you, Jeff?
So my group is code analysis and reverse engineering. We have been doing building tools to assist reverse engineers, in particular malware and vulnerability analysts, to do their jobs better. And one area that I'm excited to get into is reverse engineering AI things, AI components in a variety of different contexts, right? So when I say that it's all just software, I say that while spending my time trying to figure out how to take that software apart and find the good parts, so to speak. So I'm looking forward to, that's an emerging field, I think, in general. I'm looking forward to seeing how that develops, seeing what we can learn from the artifacts and how we can use it to assist cybersecurity folks.
Excellent. I really enjoy talking to you both, and I want to thank you for taking the time to talk with us about your work. I think I know for myself, every time I engage with a large language model, one of my thoughts is, and I wonder if there are any security issues related to what I'm asking or related to what I'm getting. I'm glad that somebody's paying close attention to this. And I did find your your categories and your recommendations. I do agree with you. They are mostly common sense, but as we know in the world, common sense isn't that common. So I hope our readers will take to heart the recommendations that you've made in terms of understanding how we can evaluate these models for their use in cybersecurity. To our listeners, I want to thank you for joining us today, as always, and we will include links in our transcripts to the resources we've mentioned in this podcast, so you'll have lots of things to look at. If I were to be a little bit flip, I could say you could probably chat GPT a question about what did we talk about today, and that would be interesting to see, once the podcast is published, if we actually got real answers to that. Anyway, I want to thank you both for joining us today and taking time to talk with us. And I want to thank our listeners for joining us as well. We will include links in our transcript to all the resources mentioned in this podcast, including the blog post and the original paper. I also want to mention that Xinghan Lao, another SEI colleague, is also an author of that blog post and the paper, who unfortunately couldn't join us today. The SEI Podcast Series is available in all the places you can find podcasts: Apple Podcasts, SoundCloud, Spotify, and my favorite, the SEI's YouTube channel. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, TuneIn Radio, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.